Snehashish, you can start now. I have sent you the new link. Okay, so we have faced some problems and we have solved it. So you may start now.
Yeah, hello.
Yeah, it is audible. You can
Okay,
start now.
okay, okay. Good evening, all. I hope you all guys are doing well. Mhm. So we will start today's session, and today we will be discussing about the model designing, right? And in model designing part, basically what we will be focusing today is linear regression and logistic regression. Okay. So before jumping into coding part, let me just take you through the story, the theory of both of these things. So, what we will do, we will go one by one. We will start. Yeah, isn't it? Hello, hello,
Snehashish, you can
hello,
start now. I have sent you the new link. Okay,
hello,
so we have faced some problems and we have solved it.
hello.
So you may start.
Why it is not? Hello, am I audible? Am I audible? Hello, am I audible? Am I audible? Yeah, hello, hello, hello.
Yeah, it is audible. You can
Okay,
start now.
okay, okay. Good evening, all. I hope you all guys are doing well. Mhm. So we will start today's session, and today we will be discussing
Hello.
about the model designing, right? And in model designing part, basically what we will be focusing today is linear
Hello.
regression and logistic regression. Okay. So before jumping into coding part, let me just take you through the theory of
Hello.
both of these things. So what we will do, we will go one by one. We will start. Yeah, isn't it? Okay. So let's start. Uh, so we will be discussing the. It's clear that you guys are seeing it, so I can say it there. So let's jump to the theory part of linear regression. Okay, then I will be taking you through the coding, how we will implement it in Python. Okay, so for that, let me just switch my window and I will be guiding you through some of the. Uh, Wait a second. Okay. Regression basically means uh, what is regression? So,
ক্লাস যদি লোক হয় তাহলে কোনোদিন চালানো যায় না কিছু।
regression in by word it means drifting. Okay, drift towards.
এখন আমার থেকে চলছে ভিডিওটা, আমি চালালাম।
Okay, so drift towards means if there is a point, the other point is supposed to drift towards that point. Okay, that is what regression essentially means. Now, uh, what linear regression means, let me just give you a brief history about linear regression. So, it all started back in 1800
5:30
century,
সময় বলে
18th
দিয়েছি
century.
যে তুই
Okay,
পারবি তো
so
করতে।
a
হ্যাঁ
name
হ্যাঁ আমি
guy
পারবো।
named
না
Francis
পনেরো তো,
Galton.
6:20 গিয়ে ওর নেট কাজ করছে না আর।
He was actually studying the relationship between parents and their children. So what he explicitly I mean, what he saw that the height of a son is likely to follow the height of his father. Okay, so the son's height is likely to follow the father's height, and in doing so, he just see if there is a man of height 6.5 6 feet 5 inch, the sun's height is likely to be around 6.5 inch. So the height of the sun is differing towards the father's height. In this phenomena, he named as regression. Okay, the previous point, the previous data of a new data is called regression. There was no concept of machine learning back then, but from this concept, we have derived so many equation, and in statistical point of view, we call it linear regression. So, what is a linear regression model does? So, linear regression model, it does what does is, let's take the same example here. Let's say there are 2 points. Let's say this is my x, this is my y. So for and the equation is x equals to, let's say, 2y. Okay, so for x equals to 2, it will give output as y equals to 4, and x equals to 5, it will give y equals to 10. So these are my 2 points. In linear regression, the model tries to find a line. Okay, essentially it calls hypothesis. Hypothesis what tries to draw a line which will collide with all the points. So we have here 2 points for x. We can have lots of points. We can have n points. So if I say one x equals to 1, 2, 3, 4, 5, the y will be 2, 4, 6, 8, 10. Right. So if I draw a line, a straight line, it will fit all the points. So this is my linear regression line. Okay, so this is my hypothesis. So if it is directly related like this, the line is supposed to fit all the points without any error. So there is no error in predicting. If I say from this equation, if I say if x equals to 15, what will be the y? Then through this line, the model can say it will be 30. So there is no error. But what if instead of this straightforward equation, we have, let's say, something like this. Then the model will try to draw a line, let's say, and the objective of drawing this line is to say minimum distance from all the points. So we have distances from each point. So we calculate the distance. Okay. So we calculate the distance and try to draw separate lines. And for that, for the line which where the distance will be least, that line will be taken as the model. That line, the equation of that particular line will be the model equation. Okay, so a model is nothing but a mathematical formula to draw a line or a plane or a curve to evaluate minimum error calculation, okay, for all the available data points. Okay, so I hope this explains how the linear model, and as this is a linear regression, this is a linear model. So essentially, this line will be linear or straight line. Okay. Although we can modify it, we can use polynomials of this. Okay, to bend it like we want to. But in the idea of linear equation or the linear regression model is to fit a straight line so that the error will be minimum. Okay. Now, when we say error will be minimum, we have studied confusion matrix last session. So there are two type of model. One is for continuous data, one is for discrete. Okay, what is the continuous data points and what is the discrete data points? Now, when we are discussing a model, the model only think about what will be the output. If the output is continuous, let's say predicting height, the example just we talked about. So predicting height. Height can be any numerical value. Let's say 5 feet 2 inch, or it can be 6 feet 5 inch. It can hold any numerical value. So it is a numerical value, and it is considered as continuous or regression problem. Okay, and what will be the discrete outputs? Let's say for the current scenario, if I say whether a person is COVID positive or not, COVID positive. So the model tries to find whether it is COVID positive or not. So answer or no. So these are two discrete answers. There is no in between, or there is no other points available for the prediction. So these are outputs. So this is called classification. Okay. Now for classification, we have the measurement matrix, which is called as confusion matrix. And what we will do if we have a continuous or regression problem? So for regression, we have three evaluation matrix or three evaluation parameter. One is called mean absolute error, MAE. One is called mean square error, MSE, and another is called root mean square error, RMSE. So these are the three parameters, or these are the three evaluation matrices using which we understand how well this model, for say this is my height prediction model. This is my height prediction model. So in this model, we will try to see what are these parameters, and then we will understand how good this model is. To understand the model's performance, we use these error matrices for regression, and we use confusion matrix for classification. Okay, so in confusion matrix we have discussed. Now let's see what are these: MAE, MSE, and RMSE. Okay, so let's just clear this out. So MAE is called mean absolute error. Okay, and mean absolute error is expressed as MAE is equals to 1 upon n summation of mod of yi minus yi predicted for I equals to 1 to n. Okay, now what is this? So this is saying there is a known output. This is my leveled output. So this is a supervised model. So we have a leveled output. So we know whether it is a positive or negative. And the model predicted some output. So sorry, it is not positive or negative. So there is a numerical value of the output, and the model predicted a numerical value of the output. Now we just take the difference of these two, take the mod, and we take all for all the outputs we take and sum it, and then we take the average, that is the mean. Up- and the n is the number of samples. Okay, so like that we get mean absolute error. Okay, so this way we can evaluate whether there is a big error or not. So, and there is a one drawback using MA, mean absolute error. Let's say we have a model
এটা খাওয়ার জন্য বটল আছে, হ্যাঁ খাওয়া
like this, and
খানিস পরে।
mm, let me just draw it a bit below. Let's say we have model like this, and there is a outlier. Outlier means a value which is way that is very different from all other values. So if I train this model and calculate MAE, so maybe the model is something like that. Okay, because of this outlier, the model goes something like that, or the model, let's say, the model goes something like this. It can predict all the thing, all the values which is in a same group or almost linearly related, but there is an outlier. So this outlier can adversely affect, or using this MAE error matrix, we cannot find the effect of this outlier, or there can be several outliers like this on that model. So to fight this drawback, the concept of MSE, root squared mean squared error, came into place. So what is mean squared error? Mean squared error is nothing but square of or the entire equation we wrote about. So yi minus yi predicted squared for I equals to 1 to n for all the values. So this takes into account the outliers and give the model error matrix accordingly, which was missing for absolute error. Okay. But there is another problem with MSE. Let's say, for example, we want to predict the height. Okay. Let's take another example for your clarity. Let's say the famous example of house prediction. So there is a price of house, and there is a let's say number of rooms. Okay, now if I predict MSE and squared it, so the output is also the square of the predicted value or the price. Now we are predicting price. If I square it, the output will be price squared. So if it is like say 15, let's say 1 lakh 50,000. That is the predicted price. If I square it, so the output will be price square. Is it making sense? So what we are calculating here, the error is not essentially the mm,
টুইলস আছে তাই না?
class of prediction. We are measuring the error of class of prediction squared. Okay. So to find this problem, what we did, we just put an square root on it. If I put a square root on it, then it is called RMS. Root means square A. So this is most commonly used error metrics to evaluate the RMSE is the most commonly used the the performance of linear
আচ্ছা,
regression.
নিজের ওয়াইফাইটা বন্ধ করো তো, আমার নেটটা ইউজ করছো বসে বসে, সারাক্ষণ ওয়াইফাই অন তোমার।
Okay, and let's say we have a linear regression, and there is a question, a doubt. Let's say how good RMSE to say whether my error is very big or my error is a small error. Okay, so let's say you are predicting a house price, and the RMSE gives you an error of say 100. Okay, so comparing the house price in lakhs and crores, right? And the RMSE gives you 100. So it is a very considerable or minimum I mean ignorable error. So this is a, if RMSE of your model gives 100 RMSE according to the house price, so this is a very good model. But the same thing, if the same model for let's say mm, uh, price of let's say a pen, if you are predicting a price of a pen and RMSE gives you 100 rupees, and the pen price essentially ranges between 10 to let's say 500, this is the range of the price of a pen, and it gives you a RMSE of 100, this is not a good model. Okay, so it depends on what is the objective and what is the output error. Okay, so to have a fair idea how your error is good or bad, you need to compare it with your target variable. So if the target variable is your price and it is very low as compared to your RMSE, then the model is very good. If the target and your RMSE has a very high ratio, then the model is not good, and you should look back with your data and modeling parameters. Okay, and one more thing, if you that is a very brief of what linear regression does. If you want to study in depth uh, if you want to study in depth of what linear model and what are the mathematical background of linear regression, so there is a book I refer you. So the name of the book is Introduction to Statistical Learning. Introduction to Statistical Learning by Gareth James. Okay. You can refer to chapter 2 and 3. Chapter 2 and 3 for advanced mathematical background of linear regression.
হেব্বি রাগ হয়েছিল,
And now,
কিছু বলবি?
with all this
এখনো বলিনি।
very limited introductory introduction of how logistic linear regression works, we should jump into the code and see how we will do it. Okay, so let me just switch over the window and we will start logistic regression, a linear regression.
বোন মনে হচ্ছে। দিনের মধ্যে লাইফ হিস্ট্রিটা করতে হবে। বাবা, কত কত করে ভিডিও সারাক্ষণ 31, 32।
Okay, so let's start with. So today we will be doing from the scratch. So there is no prior handwritten instruction what we will do and what we not. So let's try and do the coding from the scratch. Okay. So for that you open your Jupyter notebook homepage, and from then there you just launch a new
কার
notebook pad. Okay. And we will be using the USA TSV. So USA housing.csv is the just a second. Yeah. So USA housing.csv is the house price prediction. So we will be doing what will be. Okay. Now let's try and feed our data. So
দেখি তোমার
I'm
ফোনটা
taking
একবার
df as pd.read csv
ডিসকানেক্ট হয়ে গেল নাকি?
and call USA housing dot csv. Okay, as I have uploaded it here, so my homepage contains USA underscore csv. So I didn't give any path to upload it. If you don't have home at your the data at your home page, you can pass on the entire path where your data is located, or otherwise you can just upload it from here. Okay, browse it and upload it. So there are two ways, as we have seen in previous classes. So let's first see how this data looks like. csv dot.
ঠিক আছে।
So this is the data. Okay, so it says the average area income, the where the house is located, the average income of that area, the age of the house in that area, the average area number of rooms. Okay, then average area number of bedrooms, how many bedrooms are there, Mm, area population, what is the population of those areas, and what is the price, and what are the addresses. Okay, so these are the features or columns in our data set, right? So it's a good practice to check the information. So let's check the info about the data. So these are the information. These are the float values, and one area. Area is an object. So we have one, two, three, four, five, six, seven features, out of which price is my target feature. Okay. What we can also do, mm, just let me add some more. Yeah. So df dot columns. If I want to see what are the columns, did I miss it? Okay. I'm sorry. It's a attribute. So we don't need to pass on a parenthesis. So that is the difference between an attribute and a method. So to call an attribute, you don't pass any argument. Okay. So we just want to see what are the columns, what are the attributes of this data frame. So these are the columns, right? Now we will do a little bit of exploration of this data. Now, if your data is relatively small, it is a good practice to see how these columns are correlated with each other. Okay, so to see that, there is a plot in Seaborn called pair plot. Okay, so what it does, it essentially correlates each column with every other column and plots it. So let's see how it looks like. SNS dot pair plot. Okay, and we just pass on the entire data set. It takes some time. So here is my plot, pair plot. Okay, so you see, this is these are my rows and these are my columns. So all are the same rows and columns. So if I want to check the relation between average area versus price, let me just zoom in a bit. So if I want to see average area, income, and price, this is the relation between them. Average area, house age, and price. So these are the relation between price versus all other features. And if I want to see what is the count histogram of the price, so price versus price gives the counts of the price. Okay, so this is the histogram of price. Likewise, we can see the histogram plots also of every other features. So as we can see, these are almost every features are normally distributed. Okay, and average area number of bedrooms. So this thing, average area number of bedrooms, these are not normally distributed. And what happened here is, you see, 2, 3, 4, 5, 6. So these are the bins. It takes 2.5, 3.5, 4.5, 5.5, and 6.5. So there is no such uh, house which have 2.5 bedrooms. So those are like, if there is will be two or three, right? So because of that binning process, automated binning process, it looks like this. Okay, in any ways, but it may appear like, for this also it may appear not a normal distributed. If it is not, then we have to do processing. But in this case, almost all the features have normally distributed features. Okay, normally distributed elements. So this is a nice way to look into the data and how they are related to other features, right? So let's jump into our uh, target file, target column, which is our price. We want to predict our price. So what we will do, we will SNS dot function of price. So this plot. and the column of interest, that is our price column. Okay. So if I run it, so this is my column price, and this is how the price is distributed. Okay, so it is almost a normal distribution, and it is centered at let's say 1.25 something somewhere. Okay, uh, we can do some feature engineering to move it centered at zero, but we don't focus on feature engineering right now. We will be doing like this as it is, and we will see how good is the prediction. If the prediction is not good, then we can make the feature engineering process. Okay, so now let's see how the correlation of the data. Okay, by numerical means. Okay, so to see the correlations, all we need to do is type df dot cor. Okay, so here you can see the correlation between all the features. So average area income and average area income are completely correlated. So it is one. That is obvious. These are to the same column. Average area house age and average area number of rooms. These are negatively correlated. So the age of the house and the room numbers are not that much related. And if you see the number of rooms, average area number of rooms and number of bedrooms are somewhat related. So this is the correlation between the features. Okay, now if you want to plot it, what we will do, let's plot a heat map to see how these are related. So we just do heat map and pass this argument inside the heat map. Okay, and if we just do this, you see lots of uh, no relation, not at all correlated uh, features. Now if I don't want to see the annotations, so if I want to see the annotation, like what are the relations, these figures, what I need to do, I need to just pass another argument, that is a note is equals to 2. Okay. So if I run it again, oh, there is no, so there is an error. It says quad mesh object has no property anode, so must be there is a misspelling, so don't have t. Now you can see these are the correlation plotted as a heat map. Okay, so now let's now we have the idea how the features are correlated and all that stuff. Now let's move on to the modeling part. Okay, so before modeling we need to separate the uh, training features and the prediction features, or the level. Okay, so we have features and level, so we need to separate these two out. Okay, so what are my features? My features are all these columns apart from the price, right? So price is my level or my output feature or my prediction feature or my output level, and these are all these feature 1 2 3 4 5, these 5 row columns are my input features. So what I will do, I will create x is equals to there is two way to do this. Also there are several ways. What I suggest you to do, just you can do, let me just show you the simplest way. Columns, if you type columns, these are the columns, and what you do, you create a variable called x, and you pass all this
সঙ্গে শরীর ফেলে দেবে এমন, মানে ঘুম ঘুম পেলে ঘুম দরকারি, আর যখন খিদে পাবে কি তোর
all the
খিদে
column
পেলে
name.
ভাববি না এখন কাল মেডিকেল
You can pass the
খেয়ে
address
নে,
also.
তারপর দেখা
But
যাবে
as you
হোটেলে
can
খেতে
see,
হবে।
address,
হ্যাঁ
where is the
সেটাই,
address?
হ্যাঁ 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 সেইটাই। আর এমনিতে মনের অশান্তি থাকলে কিন্তু ঘুম খুব কম আসে। হ্যাঁ আমার একদিন এরকম গিয়েছে 4-5 ঘন্টা ঘুম, বুঝতে পারছি আমি উঠতে পারছি না সকালে
Okay,
5:30,
there is no address.
তাই
Okay.
ওরকম।
Why it is not showing here? There is no correlation derived because address is a okay. So the problem with this, the address is an object
একদম পটিবেন যখন
which is a
খাবে ঠিক
string,
খা।
right? So this is a string object. So the categorical and numerical value is not correlated, or
একদম
SNS,
এদিকে না
the
বুঝতে পারলে
data frame is not find the correlation between
তখন না
address and
বুঝতে পারে
other
তখন
numerical
ভুলে
values,
যায়
right?
ট্রেজারে।
So
এমনি তো ক্র্যাশ হবে না কিন্তু
what we
পরে
will do,
হয় কি
we will
শুধু একটা
just
অটোমেটিক্যালি
ignore the
ডিসপ্লে
address
হচ্ছে,
column because this is of no use
ট্রেজারের
for
মধ্যে
right now.
কিছু কিছু
We
আছে
can perhaps use this address when we
ক্লাস
do
টেন এগুলো তো
some
মানে
natural language processing and
করার
derive
পরে
some
ঠিক হয়ে যায়, পরবর্তীতেও
features
পটিবেন
out of
করতে
that,
হয় না।
or you can do the splitting method to find out some useful information from that. Okay,
সাড়ে
so
সাতটার
but
সময়
for the time being we are just ignoring this particular
আজকে তো
column
শনিবার।
as a feature. So we just featuring in the numerical columns. Okay, the column
আমি
with
আর
numerical
দেখো
values.
যেমনি
So
একবারই
these are
খেয়েছি,
my
তারপরে না
training
থাক মানে রুটি ফুটি।
features or
ও
input features.
আচ্ছা,
Okay, and let our output feature is simply the price column.
ও আচ্ছা হ্যাঁ।
This is my output. So we have
সুপটা
created
বানাতে একটু
two data
মা
sets out of the main data set.
রাজমার
That
সাথে।
is my feature and level. This is my
ও
feature
আচ্ছা
and level.
হ্যাঁ, কি জিনিস?
Okay. Now what we need to do, we need to import another library
মুখটা
called
টাইম লাগে।
scikit-learn or sklearn.
হ্যাঁ হ্যাঁ হ্যাঁ,
Okay,
ছোলে
those
ভাজাটা
who are not familiar with sklearn is the library which consists of
লাল চা
several
খাবে?
algorithms
মশলা পেঁয়াজ আদা
that
রসুন
includes
টমেটো সব
linear regression, logistic
করতে
regression,
লাগে, দিয়ে
SVM,
অনেক কিছু।
for random forest, KNN, and all other algorithms. So the
হ্যাঁ হ্যাঁ
background mathematics is already defined using in that modules of this sklearn library.
হ্যাঁ হ্যাঁ।
Okay, so you don't need to derive or
ডিমটা খাসনি
code
তো?
the formulas here. We just need to call those
আরে
modules
ডিমটা খাসনি তো?
and they will do the mathematics behind those algorithms. Okay,
আমার
so
মতন ডিমটা
we
খেতে
don't need
নেই।
to do all the
ছি
formulations
ছি
here.
ছি,
So to do that,
ইস,
called from sklearn dot model selection. Model selection is a module under sklearn,
সত্যি।
and from that module I will import
আচ্ছা যাক, দাদা
train
আজকে
test
ডিম খেতে যেতে সময় হয়নি খুব।
split.
আমার ডিম সম্বন্ধে প্রচন্ড ভয়।
I am importing a function that is called train test split. What it
আচ্ছা,
will do, it will take the
আমাদের
data
সংসারটা
and it will split the data into two parts.
সেলাব
One
করে
will be
রেখেছে।
the training part and other will be the testing part. Okay, so once we
হ্যাঁ সেটাই।
import the data, we run this. Once
সাড়ে সাতটা
we call this
আটটা নাগাদ খাবো।
particular function,
ভাবলাম যে
now
তার আগে একটু
we
জেগে
will just write
শরীরটা খারাপ,
xtrain,
একটা মার সঙ্গে কথা বলিস।
xtest,
হ্যাঁ
pytrain,
হ্যাঁ, সাড়ে পাঁচটায় কি
pytest
কিসে যাবে?
is equals to, then we call this
ও
function.
আচ্ছা হ্যাঁ 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 হ্যাঁ, ঠিক।
I'm just copy pasting it
হুম,
and pass on
হয়েছে।
my
কিন্তু দেখি না
input
টিভির
and
সম্পর্ক
level. So my
একটু
input is
কত
x
জোগাড় নেই,
and my
ইয়ার কখন
level
পরীক্ষা
is
হচ্ছে।
y.
তারপরে
Then we
ইউটিউব
pass on another argument that is
সময়
called
পেলে ইউটিউবটা
test
দেখলাম,
size.
আর একটু এটা দেখছি ওটা
I will
দেখছি,
explain what are
এই
these.
করতে করতে
Just
রনি একটা লেখ
hold on
যা
for a
লেখে
moment
লেখে শুনছে।
and then random state is equals to, let's say, whatever number you may want to give, but I am using, let's say, 42. You can give 1, 2, 3, 4, 5, 6, 7, 8, whatever number. That you need to give a number. Okay. Now, what I have done is here, I have taken four variables. Okay, four variables I have taken, and I have passed test train test split function, and in that I have given two input, that is my x, which is my input features, and y, that is my level. Okay, so this, what it does tuple unpacking. This process is called tuple unpacking. So it will split this input into two, and it will split this input also into two parts. Okay, and those 2 to 4 will be written inside these variables. So this process is called tuple unpacking. Okay, so you can create more than one variable using tuple unpacking method. Okay, and the rest of the arguments, what is this test size? Test size means whatever uh, whatever input we have given, it will be broken down in test part, that is my x test. The second part will be of 40% size of the total input. Okay, so we can vary it. If we want to give a test size of 30%, we can make it 3.3. Okay, to 0 to 1, we can give any value depending on our situation. So the common practice is to give 33%. So 1/3 of the data will be using for testing, and 2/3 of the data will be using for training. Okay, and random state is this part. Random state means the data is splitted randomly. Okay, so out of let's say we have 100 inputs, randomly selected. If I say this is my 40.4, 40%, out of 100 samples, randomly 60 samples will be taken as training, and other 40 will be taken as testing. So that random separation will be same every time we run it if we give a random state. Okay, no matter what number you give, it will separate it in particular that random fashion. So every time you run it, your train test split will have same samples. So if I run it 42 using 42, it will separate in a particular random way. If I give it some other value, it will separate it in some other random way. But every time it will be same. Okay, I encourage you to give the same digits, the same value for random state, as you will be having the same separation, so you can compare your result with this model we are building right now. Okay, so now we have splitted our data. Okay, so that ran. Now what we will do, we will be training our data, we will be training our model. So to train our model, we need to call the model, which model we want to use for training. So we want to use linear regression. So we will just call from scalar dot linear model dot. If you press tab, there are lots of linear models here: Bayes, bias, CD fast, Huber, passive aggressive. So there are lots of models. Okay, out of which we will use linear regression. So let's see where it is. If I just type, okay, so we just need to import it. So we will type import, and if I just press tab, so it automatically taken as linear regression. Okay, so this is my model. I imported the model. Now I want to create an object to
হ্যাঁ
have
তুমি তো
this model.
ওইগুলো অনেকগুলো
So
তুমি
let's say
ভালো ক্লাস
linear
করিয়েছো।
regression LR is equals to
এইসবের চোট চোটে না আমরাও কিন্তু একটু আমার মানে আমি নিজেও এরকম হয়েছি,
linear
মানে বাড়িতে কেউ এলে
regression. So I am
কি করে
having
ও
LR
তো এমনিও
object which is
বাচ্চা
the model.
ও তো
Now I
এমনিও
have the
বাচ্চাটা
model.
আরো বেশি।
Now I want to train the model. So how the training occurs? It says
হ্যাঁ
LR dot fit,
সেটাই, ওটাই তো কাজ
and
হচ্ছে।
under inside the fit command we pass
আমি তো যে
our
ঢোকে বাড়িতে
training
চান
sample
করে
X
ঢুকেছি,
train and
তারপরে সে এসে সাবান দিয়ে হাত ধরলো,
Y
বাবা আমার
train.
একটা বড় স্প্রে আছে,
Now what
সেটা দিয়ে তার
happens here
মাথা ফাতা
actually?
পুরো
Uh,
স্প্রে করে
we
দিয়েছে।
have created an object
আজ
LR
সে
which
চলে
is the
গেল
linear regression which
বসে
carries all the
আজ যে
mathematical formulation of linear
ওই
regression
বাচ্চাগুলোর
function.
পিছনে পিছনে
This
কি
function
কাজে
which we imported
কি
from our
কাজ
linear
হয়েছে
model from scikit-learn.
বাজার
Now
থেকে
once we
হাত
have created the
থেকে
object we
ডিসপ্লে
want to
থেকে সব ধুয়ে
train the object using
জল
our
শুকনো করতে
data.
হবে,
So we have
তারপর
split it
হচ্ছে
our data. So this is my this X train is for training and Y train is for training. We give these two parameters inside the arguments of fit. So it will understand. So this the first element of X train and the first element of Y train is related. So if this is the input, this is the output. Likewise, it will train all the data.
ওরা
Now, if I run it,
অর্থোগ্রাফিক না ওরা যে এটা
is the linear
ফ্যান্টাসি
regression output.
ওটার মধ্যে
So we have the
ও
linear
হয়তো
regression model and we have
পুরো
fitted the
হাত ফাত না
model.
ছড়ে গেছে।
Okay,
ইউজ
because the data is very less,
যতবার ইউজ করে তারা
so
মানে
the
দেখবে না
output is
ইউজ করে
instantaneous.
করে না
It
হাত
may
ফাত
take
কি
minutes, few minutes to few hours to few days, in fact, depending on how large your data
এত
is.
বাজে হাত হয়ে
Okay,
গেছে,
just fitting that.
এই জন্য বড় বড় রিং কিনেছে, নিজেরও তো খারাপ লাগছে,
Okay,
মানে গায়ে নিজের গায়েও যদি কিনে দেয়
so if I just
মানে ছড়ে যাচ্ছে এমন অবস্থা।
type linear
ওই
regression,
জন্য বড় একটা বড় রিং কিনে এখন ব্যাগে একটা বড় রিং আর এখানে একটা বড় রিং, খারাপ করে আমার ভয় লেগে যাচ্ছে কোন
uh,
দিকে যেমন ওদিকে তাকে বলি না কিছু,
now if I want to see what is the
হয়ে গেল
predicted hyperplane, hyperline,
মানে হাতকে
hypothesis line,
ছড়ে দিয়ে
what
আবার
my model
ব্যাগের থেকে বড়
actually
রিং নিয়ে
calculated and
যেটা
make a
যেটা
relationship of
যেটা
the
আমি সেটা
features and the outputs.
দিয়েছে,
I want to see that.
তার মানে
So
শুনবে তো না,
to see that,
উল্টে ভুল ভাবনা,
I just call
যে যা ইচ্ছা
LR
তাই করবে।
dot
বড় বড় লিঙ্ক কিনেছে নিয়ে একটা ব্যাগে একটা করে এখানে
intercept
বাড়িতে, আমরা তো বড় লিঙ্ক ছড়ি না, বাড়িতে বড়
underscore.
লিঙ্ক বসছে এরকম।
So if I just
সকালবেলা উঠে
print this,
অনেক কি যতক্ষণ পানি থাকে মনে হয় জলেই দাঁড়িয়ে থাকে, এত বাকি ট্রেনের আওয়াজ
this is my LR intercept. What is intercept,
আর জলে
by the way?
দাঁড়িয়ে থাকে তো পানি যা মানে ওদের
Intercept is, let's say you have an equation after this model is trained is
আমরা
like
কিন্তু eto জল ঘাঁটি
um,
এত তেলে
y
জলে
equals to
দাঁড়িয়েই যান না,
uh, ax uh, sorry
ওদের কিন্তু
let's say y equals to
আগে
x1
ভাজা ভাজা মতো হয়ে যায়,
ax1 plus bx2 plus c. Okay, this
জল
can be a linear model.
দু পা মুচড়ি
Y
মানুষ
equals
তো
to
পড়ি,
ax1 plus
কত
bx2
পা মুচড়ি আর
plus
কত
c.
তো পড়ি
So
বলো,
x1 and x2 are the features which we can consider here.
আমি হঠাৎ
Let's
করে
say these
যখন
are the two features
একটা
x1 x2.
কড়াইতে সর্ষের তেল
So the
ঢালা
model
হচ্ছে, নারকেল
says
তেল ঢেলে
the output y varies like y is equal to ax1 plus bx2 plus c. So here c
এসে আনাজ ভিজে
the
তবে
c
দেখো যে
the constant term is called intercept,
হাঁটলাম
and ax1 bx2 the ab is called our coefficient. Okay, so I guess this is clear. So if I let me just write y is equals to ax1 plus bx2 plus c. Okay, so if I say this c, the constant term is my intercept, and a and b are my coefficient. Okay, now if I want to see what are my coefficients and how this coefficient varies, so let's just see the coefficients.
গরম জলে সাবান গুলো সেটা আগে বগল টগল
And
সব জায়গায় গায়ে টায়ে মাখবো, গরম জল মেখে
LR
থাকো কাজে
dot COEFF coefficient.
হ্যাঁ
If I
হ্যাঁ
run it,
হ্যাঁ খাই আজকে অনেকদিন বাদে
oh,
জিরে জিরে করে ধনে
it
পাতা
will be a
তরকারি
single F, not double F.
কিন্তু পেঁয়াজ দেওয়ার ইচ্ছা ছিল
So
কিন্তু
these are
পেঁয়াজ
my
দেওয়ার
coefficients. Okay.
টমেটো
Now, if I want to see how these are related by the columns,
এ
so
করে দিলাম
we can
ঝালমুড়ির মতো
do one thing. We can just
ঝালমুড়ি একদম খাওয়া হয়নি আজকে
do the
অনেকক্ষণ
mapping of the coefficients
একটুখানি মুড়ি মাখা করলাম তার থেকে
like
এক
this
চামচ আমি খেয়েছি
COEFF.
হয়ে গেছে ঠিক আছে
Okay, let's create a data frame here.
টাটা
PD dot
টাটা
data frame, and we pass LR dot COEF underscore comma X dot columns
কাল তো রবিবার রানি ছাড় কাল
and pass
সে
the
রাত না
one
কিন্তু
column
লেগে যাবে
is equals to coefficient. Okay, and if I just print it, you see we have made a coefficient argument. Okay, so it will show you the
নিচে নামলাম
column names and their respective coefficients. So this way we can visualize what are the, let's
ওই যে
try
ওখানে
to
উঠে এসেছিস
see what are the prediction, how good our model is, how it is, how much it is, how it is predicting. Okay, so let's try to see the prediction. Let's say pred is equals to the model name that we have given, LR dot predict, and we pass on the testing data set, which is X test. Okay, now when we pass that, it has already predicted all the elements and it's stored in the pred format. Okay, pred variable, so it predicted the test sets and it is stored in pred. Now if you want to see, want to visualize how the prediction looks like, we will plot it against our y test. Y test is my the level of my test data set. So I know the levels. It in a scatter plot, it should be aligned. Okay, if the error is minimum or there is no error, it should be a straight line. So let's see how it looks like. So we can use plt dot scatter y test, that is my actual levels, and my predicted output, which is loaded plot. As you can see, all the these are my, so this is my predict actual level, this is my prediction level, and all those are almost linearly, so it is a straight line, all those are almost linearly related. So that's how we can say this is a good fit. This model predicts the output with relatively less error. Having said that, let's just use another way to see. Okay, let's use our seaborn library and distribution plot. Test plot by test and prediction. So let's put it in a equation and let's use bins equals to. So this is how the test versus prediction is distributed. Okay, so this is my price and it is distributed normal, almost normal distribution we have. There is some distortion at the top. Okay, but it is normally distributed overall, and it is centered at 0. So we can say from this distribution plot also, so this model is making good predictions. Okay, if not, that is great. It is good prediction. Okay, so this is the visualization part. Now, if I want to see the evolution matrix or the error, what are the errors we have? So let me get some notes. Now predictions. For predictions, we will import some other tools from scikit-learn. So let's import them. sklearn, matrices. Okay. Uh, okay. So there are several matrices in scikit-learn, up from which is that we introduced, that is
সবাই লিঙ্ক
MAE,
করে গেছে
the
রনি?
mean absolute error,
হ্যাঁ,
MSE, mean
সবাই
squared
লিঙ্ক
error,
করে
and
গেছে?
RMSE, the
তাহলে কোণে তো
root
নাম্বার
mean
দেখাই,
squared
মেম্বার
error. So
দেখাচ্ছে
let's
না?
see one by one
মিটে হচ্ছে না, ইউটিউবে হচ্ছে।
what are the
ও মিটিং ডিটেলস।
arguments. So we will, so let's say MAE is equals to, so print, inside print we just pass MAE, and then we will just write uh, matrices dot mean underscore absolute error. So if I click a tab or hit a tab, these are the matrices. So I will choose mean absolute error, and then we will pass the predicted output and the actual output. So y test is my actual output, and pred is my print. Mean square error. Okay, the mean square error will be matrix dot mean squared error. This is my mean squared error, and we will pass the same parameters y test and prediction. And same, let me just copy paste it.
কি গো দেখা হয়ে গেছে? ভালো আছো?
Now, root mean square
শরীর
error
ভালো
for
কেটেছে?
RMSE,
শরীর খারাপ হয়নি তো তোমার
we can
শরীর
use
খারাপ?
the
ও আচ্ছা,
np dot
এমনি হয় না?
sqrt
নাকি চিন্তা টেনশন করো?
and put it inside here. So
সেটাই,
this is a
দুঃখ
numpy
করলে
library,
হাসি খুশি
numpy
পেয়ে যায়।
library, and this is a
আরে
square root
তারপরে
function of
আর
numpy.
ওষুধ খেতে
So
লাগে
we
না, নিজেই
square root
সামলাতে
the
পারো।
previous output. That way we can have
ও
RMS.
আচ্ছা,
Let's say, let's run
আর
it.
কি ওষুধ ওই রনির
So
ইয়ে
these
যেটা
are my
ছিল যেটা
results.
দিয়েছে বেলা পাতা?
Okay, so you see RMSE,
হ্যাঁ,
it gives
তারপরে ওইটা কি দিল?
100,596,
বমি টমে গেল
which is
5-10 মিনিট বাদে,
essentially not a big
অতক্ষণ
error
একটুখানি বসেই থাকলো।
considering the house prices. So you see, if house price you
ওষুধ
see here,
ঠিকঠাক হলে আবার
it is
খেতে টেতে
4
পারো,
into
বলতো
10 to the power 6.
দম আটকে ওই সময়টা।
Okay, so it is a very nice. If I
হ্যাঁ,
this is
ওই
1.5 into 10
সময়
to the
জল
power
টল
6.
খেতে পারো।
So this is the price. Considering that the
হ্যাঁ,
error is relatively low, we
ওষুধ,
can modify the data and make it lower, make it even lower. But for the timing, this is acceptable,
হ্যাঁ,
right?
ওই
So,
ডিমের
and if
তলায়
you
যেটা
can see
রাখে,
here also, the prediction is
আর
pretty good. So
ডিমের, হ্যাঁ হ্যাঁ,
with this
সবই
uh, linear regression model, right? So
আচ্ছা,
we have a regression model LR right
হ্যাঁ
now,
হ্যাঁ, গুঁড়ো
which
করে
can predict the house price
হ্যাঁ
given. Okay, so if you give
হ্যাঁ
this
সেটাই
model we just train this much of information, it can
হ্যাঁ
effectively
তাই
calculate the price
তাও
of the
ভালো কিছু
house
একটা
in that
হ্যাঁ ধার
region
চুরি
or
গেছে
area.
নাকি কে জানে।
Okay, so with this
হ্যাঁ
I
সেটাই
have covered
আচ্ছা
linear regression. Now
হ্যাঁ
we
সেটাই
will move on to the logistic regression.
তাই তো
Okay, uh, before moving to logistic
লজিকটা তো
regression,
সত্যি
I would like to see if there is any
কোনোটাতে
doubt.
ধরাও যাচ্ছে না যেটা কেন হয় কি না সেটাই তাই তো। হ্যাঁ তারপরে আবার নিজে নিজে কমে গেল ওষুধ ওষুধ খেতে এবার আবার যেমন স্বাভাবিক আর সুস্থ সেরা। হ্যাঁ সেটাই আচ্ছা আর ভাইটু কেমন আছে?